Hello, in this video, we want to solve a problem on directional derivatives. And the problem is, what is the directional derivatives of the function phi of x, y, z is equal to 4x z squared minus 3x squared y squared z at the point 1, 1, 1 in the direction of the vector 2i minus 3j plus 6k. Now, how do we start this? First of all, it will be very important for us to understand what the question is talking about. We are asked to find the directional derivative, and that has a formula. The formula is the phi, the s, is equals to u dot the gradient of phi, u dot the gradient of phi, where u is the normal of vector, where u is the normal of vector, say v. That is, u will be vector v all over the norm or the modulus. All right, the modulus or the norm, the modulus of vector v. That is what v is all about. Okay, now to cut a long story short, we actually need to find this u, which is the normal of the vector. We actually want to do, we carry out this because we want to know the unit normal of the vector. Okay, and we know that this our v, this symbol is, we call it nabla. Nabla operator is what? Is the gradient, the grad. So if you now have grad of, that is this, it means grad of phi, of grad phi, grad phi. I hope you understand this, yes, okay. Now, that is the formula we are going to use here. That's the formula we are going to use here. So we need to understand what each parameter is actually talking about. That is it. Now, let's go straight to the point. Let's go to the point. Let's clean up the question. Let's clean up the question and start solving it. So we look at the formula given here. You observe that we find this the normal or the unit vector, and we are actually going to find the grad there with respect to the scalar operator. So we can start with the grad. Let's recall that. Recall, what is it? Grad, which is the nabla, is I partial derivative of, of the function with respect to x plus j partial derivative of the function with respect to y plus k partial derivative of the function given with respect to z. Okay, so now grad phi will now be what? I partial derivative of the function phi with respect to x plus j the phi, the y, the partial derivative of the function phi with respect to y, then k the phi, the z. Okay, all right. So it's very easy. Let's go on. Now, what follows? Fine. Okay. Now we have our phi to be given as what? Recall. Okay. Phi, since phi of x, y, z is given as, we have cleaned up. Let's get the value of phi as given 4x z squared minus 3x squared y squared z. Yes, y squared z. Fine. Okay. Now that implies grad phi will now be equals to I, of del the hex of what are we given? 4x z squared minus 3x squared y squared z, yes, plus j del the y of the same phi 4x z squared minus 3x squared y squared z, plus k del with respect to z of phi again 4x z squared minus 3x squared y squared z. That is it. Now you now find the what? The partial derivative of each of these parameters. Find the partial derivative of these parameters. Okay. Now you have del phi is now equal to I. Now you differentiate partially with respect to x here. This will be 4z squared, 4z squared, because you differentiate x, it is 1. 1 times 4 times this, 4z squared, minus, when you differentiate x here, this will 2 multiply 3, you have 6x. 6x what? 6x y squared z. Just multiply others with that value. Okay? That is when you differentiate partially with respect to x. This. Now plus j, differentiate what? With respect to y now. This everything here will be 0 because it doesn't contain y. But here, minus has separated them. So you need to multiply by what? What you have here. Okay? What we have here. So y is carrying 2. 2 multiplied by this, you have minus 6x squared yz. Please try to understand what I'm doing here, please. Try to understand. Try to understand. Can I quickly rewind? The first one we differentiate partially with respect to what? With respect to x. X is 1 here. 1 times 4, 4z squared minus, it carries an exponent 2 here. 2 times 3, 6x multiplied by y squared z. Hope you get that. Okay. Now for the next one, j. We multiply this coordinate j by whatever we get here. Now, differentiating partially with respect to y here. This one does not contain y. Everything here will be 0. But this aspect contains y. So 2 multiplied by 3, that's minus 6, because that's 6 minus here, x squared y z. Very good. Now the last one here, that is k into, okay, k, want to differentiate partially with respect to z. There's 2 here, 2, that is 8. 2 times 4 is 8, xz, 8xz. Are we together? Okay. Then minus z again, this is 1, minus 3x squared y squared, minus 3x squared y squared. Again, z is 1 here. If you differentiate partially with respect to z, 1 multiplied by everything here, 3x squared y squared. Z is having 2 as exponent here, 2 raised power 2. 2 times this, that's 8xz. Okay, beautiful, beautiful. I mean, we are moving gradually. Now, this grad phi was to be gotten at point 1, 1, 1. You can say at, let's write it better. At coordinate of 1, 1, 1. What is the value? Don't stress yourself. Okay? Don't stress yourself. The one here is x, y, z. The coordinate is at x, y, z. All right, let's go there. Let's go there. So that will be what? 4 times 1 squared minus 6 times 1. Everything is 1 anyway. 1 squared times 1. Then plus times minus j. 6 1 squared times 1 for y times 1 for z, plus k. You know, what do we have here? It's 8 times 1 minus, let's write it. We have been writing it. 8 1 1 minus 3 1 squared 1 squared. Good. So that means we have I multiplied by 4. This is everything here is 1. 4 minus 6, that's minus 2. Okay, yes, 4 minus 6 is minus 2. Then minus j into 6. Everything is 6 here. Good. Then plus k into Everything is what there. 8 minus 3, that is 5. Okay, 8 minus 3, that is 5. Yes. Okay. Now, so what do we have here? So we can now write it out as minus 2i minus 6j plus 5k. So that is the value of the grad of phi at that point. That's the value of the grad of phi. So now we have gotten the vector, the value of that vector now. Now, having gotten this, we also need to find u. Recall, our u will be v all over, that is, you find the normal, you normalize the vector. You normalize the vector. Okay? Now, how do we go about this normalization of vector? The vector given to us at what? We are asked to find the direction of the vector, beautiful, to be phi. So the vector is given to be 2i. So you can write, recall. Recall, vector v is given to be what? 2i minus 3j plus 6k. Good. So that is a vector we are going to what? We are going to use. This u will be the normal for that particular vector. So let's clean this. I think we better write the answer somewhere. So v phi, grad phi is minus 2i minus 6j plus 5k. So that we're able to remember. Okay. Now, we want to find our u. So u is equal to the v 2i minus 3j plus 6k all over. Now the square root of the x component square, y component square, and z component square. So that will be what? 2 squared, yes, plus, beautiful, minus 3 squared plus what? 6 squared. Okay, so that will give us what? 2i minus 3j plus 6k all over the square root of what? Square root of what? This is 4 plus 9 plus 36. 4 plus 9 plus 36. Okay, I hope you are following. This marker is fumbling. Let me look for another one. Okay, so this will be what? You can write it here. Let's come here. 2i minus 3j plus 6k all over root 13 plus 36, that's 49. So u is equal to, so which is going to be what? 2i minus 3j plus 6k all over 7, because the square root of 49 is 7. Good. So which invariably means 7 is going to be used to divide each of them. 2 all over 7i minus 3 all over 7j plus 6 all over 7k. So that is our u. I hope we are following. Okay, beautiful. That is our u. Now apply the formula by substitution, since directional derivative, that is the phi over ds is equal to what? U dot grad phi. Another way of writing this, the phi, you can say, or you can say, directional derivative of u of phi with respect to the direction u is the same thing as writing what? U dot grad phi. Okay, and don't forget the grad phi at what point? At 1, 1, 1. Can we still remember the value of grad phi at 1, 1, 1? Yes, I think we can remember that. Okay, now And our u now, we have gotten u to what? Which implies 2 over 7I minus 3 over 7j plus 6 over 7k. Now dot, you are multiplying with, it's a dot product now. Our graph file at 1, 1, is minus 2I minus 6j plus, I think it's 5k. Okay. Hope you're following. Good. So, what's next? In dot product is for, call it what? Divergence. We have this vector formula, we have gradient, divergence, and coil. So now we want to carry dot product. Recall, in dot product, recall please, I dot I is 1, j dot j is 1, k dot k is 1. But if you are multiplying I dot k is 0. Once the coordinate points are different, the result will be 0. So that is why in dot product, I put dot here. Remember, there's a dot here. In dot product, you multiply point-wise or coordinate-wise. So in this case now we have what? So now have the directional derivative with respect to this u, is equal to what? 2 over 7 times minus 2. That's 2 over 7 times minus 2. I times I is 1. So you just multiply coordinate-wise. 2 over 7, that's minus 2 times 2 over 7. Then plus minus 3 over 7 times, for j now, minus 6. Plus the last one, 6 over 7 times 5. K multiplying k is 1. Okay, you understand now? So you multiply coordinate wise with the one for high, the one for j with j, and the one for k with k. So here we have minus 4 all over 7 minus 3 sorry, 3 times 6, that's plus, it's a plus there, plus 18 over 7 plus 30 all over 7. Let's check the sign very, very well so that we don't run into trouble. Plus times minus, yes, this is minus, good. Minus times minus, that's plus, fine. And plus times plus, beautiful. So, finally, our LCM is going to be what? 7. Good. So, this is going to be minus 4 plus 18 plus 30. So, what is minus 4 plus 18? That is what? 14. 14 plus 30 is 44 all over 7. So, the directional derivative of this particular problem is 44 all over 7. So if you enjoyed this video, kindly give it a thumb up, share, comment, and like. God bless you.